everyone. As you know, yesterday we have done the topic electric field intensity due to dipole on the axial line, and today's our topic is electric field intensity due to dipole on equatorial line, or we can say it as a transversal line. Basically, what is equatorial line? As we know, these are two dipoles. This is minus q and that is our plus q, which are separated by a distance 2l. But we have to take the distance from the center point. So the distance between this minus q and of this point is L. Same, this distance is L. Now equatorial line is that line which joins from center to a particular point. This line is called the equatorial line, or we can say it is a perpendicular line. This perpendicular bisector is known as the equatorial line, and we have to find the two different electric field because of these two charges, that is minus q and that is plus q. Now you understood about the system of dipole. Here we are having minus q dipole charge and here we are having plus q, which is separated by 2l, and that is our equatorial line. Now we can take any unit test positive charge. As we know, this is plus q charge, and plus q charge will repel the positive unit test charge, and it is applying force in that direction. This is plus q charge and this is our unit test positive charge, and the force that plus q will apply in that direction, because it is repelling, and if it is applying force in that direction, same for the electric field also. Electric field will be also in the same direction, and in this case this is a minus q charge and this is our this is a unit test positive charge. Now this minus q charge and this unit test positive charge, this will attract towards it. Here attraction will be there. If it is attracting towards the minus q, so same case will be for the electric field, means electric field will be in that direction. Here our electric field was in that direction, but here in the opposite side. Now come to the some geometrical part. What we will do, we can, this is our equatorial line, means these two are equal motion, so we can consider is at theta. This can also be theta because these are two equal segments. Now little bit construction part. What we will do, we will do a construction line over here. As you can see, these two lines are parallel. If these two lines are parallel, this is angle theta, that will be also angle theta. Why? Because of alternate angle. Same, this is angle theta, and here also we can take as angle theta because of correspondence angle. So do you understand about how we have contributed the angle theta? Now our further main topic is, we have divided angle thetas. Now we will discuss about the electric field. As we know, we got two electric field, one in that direction and other one is in that direction. Means we are having two electric field, one is in that direction and other is in that direction. And here we have given the resultant of these two electric field. This is our resultant. In plus 1 class you have done about the vector addition or vector resultant. We have studied about the resultant of vectors. Now what we will do, we will resolve these two electric field in two components. As we know, when we will divide into two components, one component we take as horizontal, other component we take as vertical. Just see this electric field. This one electric field we are having. This one electric field, one component will be horizontal. Just see this one electric field direction. One component is going horizontal, that is E cos theta. One component is going vertical, that is perpendicular to this electric field. One is going horizontal, that is E cos theta. Another one is going perpendicular, that is E sin theta. That we have discussed about one electric field. We are having two electric field. Now come to the next one. This is a second electric field. Again same thing. The methods of vectors. One component will be E cos theta of this electric field. One component will be E cos theta, and the second component again perpendicular. Of this electric field we draw perpendicular over here. Of this electric field we will draw perpendicular over here. That will be horizontal component, that will be vertical component of this electric field. For this, that was horizontal component and that is a that is a perpendicular or vertical component. Now this E cos theta and this E cos theta are along the same direction, but these two are in the opposite direction, so they will get cancelled out. We got two electric field components, that is E cos theta and E cos theta. Both of them will get added because their magnitude is same as well as direction also. Now just try to find electric field due to this minus q. When we will in the last topics we have done electric field is equal to q upon 4 pi epsilon naught into 1 upon distance between two charges. Here 1 upon d square is the distance, and what is E minus? Now we will take q upon 4 pi epsilon naught. Now what is the distance for the minus q from its center? That distance we have taken as L, that distance we have taken as R, and our main distance will be AP. We can take it as AP here, BP. By applying Pythagoras theorem, we know hypotenuse is equal to base square, you can take as OA, base square plus perpendicular square. So AP square, OA we are having, the distance OA is equal to L square, the distance OB is equal to R square. So we got the distance AP square is equal to R square plus L square. So we can put over here 1 upon R square plus L square, because we are putting the value of square of the distance, not only the distance. So square of the distance is equal to R square plus L square. Same for the positive electric field. Q upon 4 pi epsilon, same will be the R square plus L square. Now this is for the minus and this is for the positive. We know magnitudes are same, so we can assume it equal. E positive is equal to E negative, that is E total. Now E total we can take is 2E cos theta. Why? E cos theta plus E cos theta, it will become 2E cos theta. Now just put the values. E total 2. What is the value of E? Total E. Q upon 4 pi epsilon naught R square plus L square. And cos theta. Why we took cos theta? Because our sin theta components were cancelled out and we got only cos theta. So by proceeding we can see this thing. E total is equal to 2 Q upon 4 pi epsilon naught 1 upon R square plus L square. Now cos theta. As we know in the trigonometry you have done, cos theta is equal to base upon hypotenuse. Cos theta is equal to base upon hypotenuse. So what is the base? L. L is the base, you can take either side or this side. So what is the base? L, and hypotenuse we already found, that is R square plus L square. So we put the same L upon R square plus L square half. Clear this thing or not? Now E total we know Q, we have studied in the last topic, dipole moment is equal to Q into 2L. So Q 2L, by combining this we got P, that is P upon 4 pi epsilon naught 1 upon R square plus L square into 1 upon R square plus L square 1 by 2. Now just consider if R is very much greater than L. If R is very much greater than L, then we can neglect the L, and if we will neglect the L, this L will be neglected, this L will also be neglected, this 2 will get cancelled out by 2. We are having R square into R, it will come 1 upon R cube. So our electric field will become E is equal to P upon 4 pi epsilon naught R cube. So that was our topic of electric field intensity due to dipole on equatorial